there, Dawn here. In this video, I'll be showcasing my latest projects with my dad here.
Am I your dad?
Hope so. Right.
I hope so too. Dun, dun, dun. Okay, cool. So I gave you 1 week to change the world. Have you done that?
No,
You're
but
13, yeah?
I
You're
have
13
not.
years old, you're a man. What have you been doing for this last week?
Making essentially a 1960s computer, but worse, but less useful. It's
Okay.
quite cool though. So it is a 8-bit
hold on
computer.
before you go there. Okay, let me ask some questions. So you've had a week and you've been playing around with, what is this called?
Logisim
Evolution. Okay, great. What the hell is that?
Okay, so it's the upgraded version of Logisim, which is a digital logic simulator.
Okay, so you have to be slightly logical to use it.
Oh yeah, that is
A
the
logic-
majority of the thing, the logic.
Okay, cool. So why and how did you find this and what was the point to it?
Well, there are 2 points. Number 1, I thought it would be quite a cool project, and number 2, I was bored and I kind of wanted to try something else.
I think you were very frustrated, hey? You've been struggling for the
Yes.
last 3 months.
Lots of failed coding projects, so
Yeah, lots have failed, you know.
Trying
Trying to take over the world, but you couldn't.
yeah, unfortunately it was quite hard. So
Okay, so you've made something interesting. You've made a CPU.
yeah, it's a full computer and only a CPU. So
Okay.
we have the teletyper
Okay,
here.
but hold on. Okay. So I had to find out what the hell you were doing for the last week because I literally locked you in the room. I threw away the key and I said, change the world. So I asked some questions because I didn't know what the hell you were up to. Okay, so I asked AI to help me so I don't have to deprecate myself. Was it deprecate?
Yes.
Deprecate myself too much? Good, it's not depreciate, is it?
Yes. Yeah.
Both. Anyway, cool. So you built an 8-bit CPU from scratch in Logisim Evolution. So it has registers.
Yep.
It
Here
has
are the
RAM.
registers. I've just find the registers. There's the registers here. They're in here.
It has an ALU.
So there's RAM. There's the ALU.
What is an ALU? What does it mean?
Algorithmic logic unit. And here it
Okay.
is. So it can do calculations. So it can do plus, minus, multiply, divide, and greater, equal, or less than. And some bit shifting here.
Okay. And a crazy thing that you've done is you using the microcode controller units, or you've actually developed microcode. You know, maybe you can explain what the devil microcode is, because it's that invisible, it's the Phantom of the Opera, isn't it?
Yes. And
What is microcode, and do people actually see that?
So
See it.
So I'll explain what normal microcode does in a proper CPU, like my Mac CPU, and then I'll explain how this computer does it, because it's slightly different.
Okay, great. So what is microcode?
So what a real microcode is, it doesn't really have a language. All it is kind of just, so it has assembly. You don't actually code in microcode, and you can't code microcode. It's just a bunch of logic gates normally. So you have RAM, which runs your assembly, and the assembly has a bunch of individual instructions that call certain, in this case, a bunch of booleans. So let's say writing from the bus to writing a character here, or moving something from the ALU over to RAM. In assembly, you may notice it's quite simple. You just say move, MOV. However, in microcode, you have to enable bus out, you have to enable the RAM in, you have to set the address. It's a bit of a mission to do anything in microcode.
But why did you want to do microcode? Because it was the invisible code. It's the invisible type of...
Well, the real reason is that's a great, it's a great idea, but no, the real reason is because assembly, it's quite a big project, and it's kind of hard because I have to have even more clock shenanigans to try and get everything working, which is already a pain because I have 6 clocks here.
Okay, so basically I asked Chat to help me decipher what you've been doing for the last week. So just to walk through the key parts.
Wait, 1 second. So I just say, so this is like assembly. However, assembly is able to run multiple microcode instructions all at once, right, in one command.
Okay.
So it sets each of these separately. It can set multiple of these in one command.
And
This
these
microcode, this is like assembly, but a worse version of it, where what it does is you can only set one of these individually. So assembly can set these multiple at once, which lets you have high level commands like MOV, which can set quite a few of these all at different parts.
Okay. So basically, it's a computer. So it has register as a CPU too. It's mainly the CPU too, right?
Yes.
So you've got the registers, the RAM, the ROM, the LU.
Yep, here are 16 registers.
Why 16?
It fit best with a 4-bit value, and the reason why I'm doing 4 bits is, number one, it's half of 8-bit, which is it's a nibble, as they say, and it just makes life a lot easier.
Wish I had some biscuits to nibble now.
Your tea, yes. So and it's actually not 16 general registers. So general registers are registers you can put any 8-bit number in this case. So if you have a 16-bit computer, you could put 16-bit numbers in here normally though. So we have the program counter, which is an 8-bit number, and we have these two special registers, which are for the RAM address. And the reason why I have two is so we have a memory module register and a memory virtual register. And the virtual register is a virtual position in RAM, which is 8 bits. And then we have the module, which we have 256 modules in our 16-bit address RAM. So we have quite a lot of RAM.
Yeah.
For an 8-bit computer at least.
Okay, so, I just want to go back to why the assembly, because it's difficult. Maybe you can explain to us dummies what is assembly, and just also why you skipped it. Is it because it was just too complex, or was it basically, why did you skip it? Why did you go directly to microcode?
Yeah.
Maybe
So
perhaps you did kind of say the reason.
Yes, the main reason why is because this current version is quite hard.
And this is your first time you've ever done this, right?
However, what is very nice is if I just modify this, right? Make a slightly more complex version where instead of running microcode, which only runs one of these, which can only set one of these at a time.
One of these values.
One of these special registers, right? These kind of hidden hidden registers at a time. We can have assembly which can set multiple at a time. Then in a specific sequence, and by the way, the reason why computers don't let you use microcode is because you could short circuit your computer's main bus by setting, let's say, the ALU to output and let's say our RAM to output at the same time. In assembly, you just can't do that. Okay. So it's a bit of a safety thing as well.
Okay, so...
Which are mainly because it's too complex for now. I just wanted to get something working, but it will be easy enough to modify.
I mean, when we had this argument earlier about, this is more logic than transistors and stuff like that. So, I mean, basically, it's difficult to kind of convey
yes, so
that.
electronics is... Well, you have to handle voltage and resistors and to make sure things don't burn themselves out.
But if you printed this, technically it would be a circuit. It would be a circuit board.
Well, if we made it in real life, then it would have to use electronics.
Yeah,
There's no magical digital logic.
Yeah.
But in this, I'd use digital logic because I don't have to worry about voltages or anything like that. So I don't have to worry about specific specs.
Well, I suppose before we carry on, what is actually your intended purpose for this monstrosity?
Well, the intended purpose is to try and make a tiny little text game, like, I've forgotten the name of it, but it's a lot simpler. So it's like a terminal-based game, like those kind of little questionnaires you might have made in terminal at some point. It would be something like that, because I have a teletyper and a keyboard, which you can write text in, and you can output text.
So is that the Hello World one? What do you wanted text-based games? So it's got it does a teletyper and it does print, and what else have you been able to to do currently right now?
Well, you can do calculations. You can have if statements, or a kind of if statement, which you jump to a certain position if something is equal.
So maybe show us what it can do
Yes.
for the time being, and then maybe expand on that.
Yeah, so
how
I have a
you can
few
do it.
demo programs set up. So if I just go Command R to reset everything and I load the image into ROM, we have a few little demos I've set up. So let's say hello world.hex. It's just a hexadecimal file, and I'll show you the actual code in a minute. If we open hello world and we go simulate and we run it.
So what is this 50 hertz thing? 0.5
Yeah, that's
hertz?
just the clock speed.
Okay. So did you have to set that or?
Yes, we can set it a bit faster. So let's just make it 32 hertz so I don't have to wait hours for it to load. So hello world. There we go.
Okay, I probably killed myself by that, but it is exciting to kind of do something where you build something totally in a logic format which interprets a real life computer. Yeah. So could you see what is the potential for this?
Yeah, the potential would be to try and run a text-based detective game or something like that. But I think I would try to do that with assembly, because assembly is just so much easier and more high level to write than microcode. Trust me, I've written this tiny little program.
So you're probably the only one in the world who's done this.
Don't know, maybe.
Maybe, huh? Something as crazy as this. We should ask Chat just to...
You and your Chat, eh?
I love Chat. But just to kind of give
right, so this is probably the most complex program I made in microcode.
So you have developed this in microcode. Maybe you can just, before you do the next one, you've done the Hello World, which is great.
Yeah.
Can you show us what actually these little programs, you developed this computer and now you've built these little programs, these mini programs. What does this mini program, the microcode, look like?
Yep, and I will show you. So if I go to Xcode and I'll just drag it in.
I'm seeing something that looks very easy to understand.
Actually, you say that. Yes, it is incredibly easy to understand. This is like the high level nice stuff.
What?
Yeah, this is the high level nice stuff. This is the alphanumeric version, but it's get compiled. I made a little because for my sanity, I won't code this in binary. Although, so I made this little Swift program that just converts it to binary. It doesn't do any computation. It just converts this code into raw binary and makes it so I can say no op and move manual bus inputs and just these nice commands I can actually read.
Okay, I obviously I'd have to learn those.
Yes.
Yeah. Painful. It's like another little more clutter in my old brain, my half-century brain. Okay, cool. So that's interesting. And how did you come up with? Is this proper microcode?
Yeah. Well, generally microcode isn't actually written, but if it was written, it would and it was slightly high level, well, not high level. It just had some nice user-friendly stuff. Then yes, it would look something like this.
And then you obviously had to write a.
But I can show you what
parser,
I can show you what the real microcode looks like actually. So
can you show us the parser first, though?
The parser, I don't.
The parser in the sense of what you did with the microcode to make it with your code.
Yes. So if we open Xcode, go main.swift.
So you wrote this in Swift, right?
Yes. Just because I like Swift.
Yeah, Swift.
So we have microcode parsing. It's a big script. It just converts. It does some mnemonics. How do you pronounce it?
I can't even see it. I'm blind.
Okay.
Where is what? Yeah, Kara.
Anyway, I just have a bunch of these commands like halt and no op and out and register read that converts to binary.
Okay,
A
cool.
binary number, and then I convert everything to binary because something like this, like hexadecimal or 0D, I make as saying as decimal, although you could just write it like this. That was a later addition after I wrote this code though.
Yeah.
So it doesn't exist yet. But it converts it to binary, and if what I can do is I can just go over, let's just scroll all the way down. Okay, here we have the actual writer, and if we get the output path, let's see, where is my hex values there? Output string. So if I just go print output string, so this is what the actual computer reads And that is kind of painful to write, so I'm not going to do that.
Yeah.
This is all in hexadecimal, though.
Okay, cool. Yeah.
So this is... this is a hexadecimal conversion. As you can see, it'd take forever to try and write this. I actually wrote a computer quite a while ago, which was only 4 bits, and it was even more painful because I never set something like this up, so I had to write in
These
binary.
helper programs are really great.
Yes, I was considering doing an assembler, which converted to this, which then converted to this, but I decided against it. I just do hardware assembler.
Yeah. Okay, so I'm still wrapping my head around what you've done. So you created this in this logic system. You built a whole computer, and now you're trying to build little games using something that was never meant to be used as a programming language to write the games.
Yeah.
That's
I don't
crazy.
think many people have coded
I don't
their
think
game.
anyone in the world has done this. That's insane.
And for very good reason. It's bloody painful. Like, you wouldn't believe how long it took to write this. Oh, so painful. And I wrote, this is the second version, which I used the nice upgraded version of this, because in the older version of 8-bit microcode converter, I didn't get to write A. I had to have a spreadsheet of all the different 7-bit ASCII characters. Oh, such a pain to write, and it broke. And
Yeah.
at least it's slightly more readable now with the hexadecimal characters. And
Yeah, but you're excited doing this, right?
yeah, but yeah, it's quite cool. So as we see here, we have jump equal. So what I'm doing is this checking if the number you inputted on the keyboard is equal to 7. So here we just write RU equal to 7 with Y or /n with a question mark.
Ah.
Right?
Okay.
And I decided to use U.
Yes, I like that.
Right, then I made it so that we load 7 into the special registers, E and F registers, which are for the ALU, and then I subtract them. So here there's a subtract, a D1, just 1, and I can show you that in Logisim if we just opened here, go ALU. We have a multiplexer here, and as you see, 1 is the second one, which is in minus. Right, and if we subtract them, open Xcode, if we subtract them together, it should equal to 0. And if it's equal to 0, it will jump to the address 37, which will just print
It's very
out
manual.
Y. It is incredibly manual, yes. So assembly will be a lot less painful, but otherwise it prints in.
But this is the first iteration of this computer.
Which it's quite cool actually. Is if I can run it. So if we load it and
so where's the second program that you developed the game? What's the first one's Hello World, obviously to establish you could tell you.
Okay, first I can show you ALU multiply.
So what does that do?
Right, this multiplies 2 numbers together, 7 and 4. I've hard coded that.
Okay, just to give
Although if I make it more complex, I can just make it so it's inputted the items. I'm not sure though. That's just like I could make it a very basic calculator that's painful to code in microcode. Maybe I'll do that with the assembly one though.
Yeah.
But yeah, Command R, reset it and run it. And this is actually a live display of bus. Let's just make it slightly faster than 0.5 hertz. Say 32 hertz. So it loads 7 and 4, right? So it's 7 times 4, which is 28.
And all these little cute little flashy little things.
Here's a very satisfying clock signal. Yeah, this particular part here is pulsing the program counter, which is this.
So maybe you can explain to the pulsing and the clock speeds and the different clocks and the different that kind of stuff.
So clocks was incredibly painful, but I finally got it right. So I have a bunch of different specific clocks. So
what do the clocks mean in maybe
right, so clocks are just running things have multiple clocks to run different things at very specific timings. So, and I've always had it at the same time.
So we spoke a while about the synchronizing things.
Yes.
You know, do you synchronize stuff or not really?
Everything's synchronized properly in a
Okay.
very specific order.
Okay.
So at clock number 1, we get the command, which is done. Get command. Yes. So clock number 1. Oh, maybe I changed it. Whoops, I'm reading out just slightly outdated stuff. Sorry, I changed this computer quite rapidly. So clock number 1 is for something else. There it pulses the program counter. Pretty sure, yeah, program counter incrementing, which is quite a big thing. It's quite messy and ugly, but what you're going to do? I'm sure there's an elegant solution for this, but
So what does it do? What
the reason why program counter thing is so messy is because I need program counter as a general purpose register in the normal registers. And the reason why is so the user can set it using normal register read, register write, such, and so on and so forth. So, but it's just a mess of OR and AND gates here. So it's a bit ugly, but not much I can do about that. Right, then we have clock number 2. So on the second clock pulse, it updates all the microcode values. So assembly will do the same thing. Okay, and clock 2, and on clock number 5, clock 3 and 4 just do different miscellaneous things around the computer. But on clock number 5 is the biggest step. It is the main clock. It updates a majority of the just stuff in the computer. So RAM, for some reason that's disconnected. I haven't tested RAM yet, so.
Are you still doing RAM?
Yeah, I'm still hooking up RAM properly, but it will update stuff like the ALU and a couple other things. It's just around the computer and RAM and the registers here. And then clock number 6, finally at the end of running everything and just updating everything, we finally update the keyboard. Not the keyboard, sorry. We update the monitor, the display, so we can display what's on bus right now.
Okay, so that's interesting.
That was a mouthful.
It sounds very manual and boring, but it is interesting. And
yeah,
if you're dead.
Why, thank you very much.
No, I'm just joking.
But yeah,
no,
by the way,
awesome.
here we have the two jump equal or jump not equal, which just jumps to a specific it sets the program counter to whatever position you've inputted to it just jumps to whatever value of the program counter if the
So is that your if statements that you created?
Yes, these are if statements. Okay. These are microcode and assemblies way of if statements.
Okay, so maybe you can explain how you need if statements so that you can maybe in the future create real games.
Well, you need if statements for anything to compare anything or jump do anything.
You're right.
Yeah, so in the ALU here, what I do is I have a bus out. However, bus out has a tri-state buffer. So, and that's
what does that mean?
Oh, it's just a buffer with a switch on it.
Okay.
So I can enable or disable output. Because I don't want it to ALU to spit out whatever it's currently been inputted all the time to bus. Yes. So it's enabled by ALU to bus. ALU write. And the result register is being outputted to this, which is just a miscellaneous thing. It just goes to other places in the computer in future. I don't think I've even used it yet, but I will at some point.
Okay, can you show us another
And
program?
here is the equal, so it just compares if it's equal to 0. Yeah. And that takes it to the registers as well in that big mess pile.
So how did you get this idea? Where did you steal the idea from? Did you look at an old computer?
I didn't really look at any old computers, but I didn't, to be honest. I mostly stole it from myself, because I stole it from an older designer.
How can you steal it from yourself?
Yes, I know.
I stole it from myself.
Yes.
No! How did you do that?
Yeah, I made an older computer and I stole
Your past life.
I stole a bit of the computer from another program, from myself in an older computer in another program. But so it was quite different though. So this is pretty much an entire redesign.
So you're an old soul. Okay, so you stole it from an older version of yourself and you're 13, what you were like, what, 3? What do you mean you stole? How do you do this with you can't, how did you do this if you didn't steal it? Who taught you this stuff? I gave you a week. I didn't give you 10 years.
Yeah, I mean, it's relatively easy. I quite like it though. I love logic.
Okay, so you didn't look at the but if you say that you were kind of out of pixie dust, formed this out of pixie dust, when you look at this and you perhaps look at other systems, do they merge? Is there parity between them?
Well, you see, I would look at other systems, but this computer is so simple. This is like a 1960s computer.
Okay.
And unfortunately,
so have you looked at
there are
the
not many
1960s?
There aren't many logic
shit.
blueprints of them, it seems.
Okay.
I'm not sure. Maybe I'll look again, but...
And just make sure that what you've done
This is quite hardware specific, because 1960s computers also weren't designed to run games.
Yeah, perhaps not. Like 1 + 1. Yay, we did it! 1954.
Right, but...
With massive fat transistors.
Oh, by the way, so over here, I'll just zoom in. We have manual bus and manual bus input. So this is when you want to write directly to bus.
Why would you do that?
So that's if you need to load in a specific value. So what's quite cool is if I open Hello World here, shows this quite well. So I do no operation. Okay, that's just to start off. That's just to boot up the computer, give it time to get the clocks warmed up.
Does it need that, or do you just have fun with that?
I'm pretty sure it needs it. Oh, by the way, I did make this computer. I didn't just nick it off the internet. I did make it. I know it doesn't sound like it, but I did.
I mean,
Okay.
obviously, I know you, like some days you will not know what you did the previous day. You need a kind of, it's difficult for you.
I think with because you see the older computer, I did need this. But with multiple clock signals, I haven't tested it without it to see if it works.
Yeah. Okay, cool.
Oh, well, it's probably good to boot it up.
Yeah, cool. So
let
you
the
go
clock,
through it, you
let the machinery
spin it.
logic
It's almost like one of those things
Yes,
like
exactly.
the old-fashioned cards, right?
Right,
Okay.
so I load in H, then I go manual bus mode, enabled. So it writes H, writes H binary value, which is 7 bits, to the 8-bit bus. And that doesn't matter, just appends an extra 0 to the end. And then I enable output. So this prints out H and outputs. As long as it's on, it will print out whatever value is on clock as an ASCII value, as a 7-bit ASCII, every time clock number 6 pulses.
So how did you come up with the bits? How did you conceptualize the bits, the 8-bit, the 6-bit, the 4-bit? What pushed you in that
Well, it's
direction?
just most of the older, very old computers are 8 bits, and also it just works so well 8 bits. It can be cut in half as a nibble. It can be cut into even smaller. And most normal real computers also use 8 bits.
Okay.
And it can be easily fed into it's just a byte. It just makes life a lot easier than, let's say, 6 bits or 5 bits. And it's even. It's just a lot of advantages, and it's tried and tested as well.
Yeah.
And you can get little logic.
In your older mind.
Yes. Yes. But yeah, and clock number 6, it prints whatever is on bus. What's quite nice is it'll print it over and over and over again until you disable it. So if we go to Xcode, as you see here, we have out, and then we can just load into bus, ELLO, so on and so forth. Right? Each one takes exactly one not one clock cycle, but one, what would you call a clock loop, let's say. Okay. Right? One clock loop to load in. Each command takes one clock loop.
It is a cycle.
It's not quite a cycle though, because, But it will print out each letter individually, because this is still on throughout the whole program. And at the end, I never even had to disable. I just go halt, which is a new command I've added this morning. Just because some of the programs don't have halt yet, and others do. And yeah, this one has halts here.
Halt!
Yes. So we have, unfortunately, for some reason, I had to add no operation here before running halt, because I guess just yeah, just to give it a second, because for some reason...
And I suppose, in a way, you need to
it
understand...
kind of cache, it's still running.
You've only done this for a week. You conceptualized this idea, but I think you had a bit initially in the past. But this is a week old. You've been working really hard, right? Like at least 12 hours a day. You're going to shrivel up and die one day. Look at the dark rings under your eyes. Good gracious.
Good luck. But
Okay,
yeah, I
cool.
think I'll finally show you actually what the equal to 7 is, .hex.
So what does this do?
So
Is this another program?
Yes, this is another program.
Okay.
So if we go simulate, we must run this relatively fast, because it's quite a big program.
So what does this
for this
do?
computer. So this checks whatever number you inputted, it checks, is it 7?
So it's not supported on the left-hand side. Is that just your...
Oh, it's fine.
Okay.
I'm sure it's fine. I mean, just wave it away. All right. So So is E 7? Is E 7? Well, let's see.
And you hard-coded this,
Yes. So are you equal to 7? Yes or no? And it does some very complex computing here. And no, E is not 7.
Okay.
And
so
it
there's your
holds.
if statements kind
Yes,
of
this is
working.
if statements.
Okay.
And if I go reset it again, let's check if 7 works. It wouldn't it be funny it failed. That'd be rather embarrassing. Yes or no? And does computing again, and yes, why? Yes!
Okay, cool.
It works.
So is that your second program that you generated?
Actually, this is the latest program that I made this morning as well. Lots of stuff to
Okay,
do.
cool. So, and what do you see a little bit more? How much can you load? You said RAM, so you haven't done RAM now. You need RAM to load more stuff.
Yeah,
in, right?
all the programs are in ROM.
Okay.
It doesn't need to be... I just ROM, I made it separate, and it doesn't matter. I'll be replacing this with the assembler soon. Sheesh, look how fast that clock's going. That little clock's going, and it's trying to whir, because if we just... So as you see, we have the quite satisfying pulsing of each clock in a very specific order, one after the other.
Yeah.
Maybe for another YouTuber, I could make like 11-hour loop of that.
Cool. Okay, great. So
Lots of whys.
I think we've kind of answered all the questions. I should ask chat what kind of questions we can ask on what do you intend to do with this? How far do you want to take this? It's quite interesting. It is interesting.
Well, preferably, I'll make an assembler for it. So I'll make it hardware assembly. And I will see, with the nice high-level assembly, that's so much better than microcode, I will be able to write a proper little game, like a tiny game that must fit in 64 kilobytes of RAM. And yeah, I've quite not very many instructions, but...
Yeah, what type of game could we do?
It'd be kind of those like terminal games.
Yeah.
Not like any display, just like a text. Like you walked into a dungeon, you go left or right. And
Yes, yeah.
You know
okay.
that kind of game. I was like, yeah, it's like maybe even a questionnaire. I'm not sure though.
Yeah, okay, that's interesting.
Yeah, a questionnaire could be quite cool.
Yeah, I mean, I don't think anyone's ever done this before. Very few people have done
Yeah.
something like this at the age of 13.
And then you see this one crazy guy who made a 16-bit computer with a video display and going...
Yeah, but he was
Yeah.
probably about 45. And in his mom's basement.
Yeah.
I hope you're not going to be 45 in my basement. Trying to hack the world. Anyway, that's very interesting. Yeah, I thought it's very cool. I think definitely did something that no one else has done. Very unique. Cool, man.
Well, someone else in 1960 has probably done this as well, but
Yeah.
this was the size of the room, and probably slightly better actually than this broken calculator.
Yeah, but you did it in a week, and you conceptualized it in a week with
Oh, well.
very little help.
Yeah.
So I think that's
I guess the
amazing.
next thing is trying to upgrade RAM, and what's nice is because I'm using these tunnels, you may notice by the way that everything's very segmented, I love it. So I'm using tunnels, so as you see we have a tunnel, and if it has the same label it will link it. So which means I don't have to have hundreds of cables. You see how messy it could get, even with tunnels it's quite messy. So
Yeah.
imagine having to connect each of these, it's just what's nice is I can strip away all this and just leave these registers here, which assembly can run.
So, I mean, in a way, you're showing people
So it's
how
nice
to
is once-
develop a computer, to actually visually develop a computer from scratch.
Yeah, so in the next few days, I'll probably try and test everything, make sure it's bulletproof, this beautiful contraption I've made. Make sure
Yes.
RAM works, the RAM addresses, Oh, by the way, I forgot to show this one component. So it's virtual tube position, very basic. So all it does is it has a RAM module, and as I said, it's just like another part of the index that's, I have 256 virtual addresses.
Okay.
So in the end I have 64 kilobytes of RAM, which is quite a lot actually.
It's not too bad.
In 16-bit computer, I actually wouldn't have to do this weird RAM module and RAM virtual thing. I wouldn't have to do that because I could do it in one command. Because of this 8-bit though, I have to do it in both. Which is...
Why?
Yeah. Because the bus, I have to load it through the bus. Let's say you're doing manual bus or you have address for some reason in the register. You could just load it in. And it just wouldn't really work with 8 bits because for obvious reasons it's 8 bits and it can't load a 16-bit address.
Yes, okay.
And obviously I could make the address 8 bits, but I'll show you. It's only 256 bytes, which is it's pathetic. I mean, look at it. How are you supposed to store anything in here?
Yeah. No, I agree.
Like maybe you could store a tiny little text thing, but it's nice to have a bit of RAM.
Yeah, no, absolutely. Okay, so that's very interesting.
I think
so, I mean, if people want to learn how computers really work, then they should use this logic.
Some evolution.
Evolution.
You really have a problem pronouncing it, but I do love it.
I do have a pronunciation problem with this word. Logisim. Okay, yeah, I've got it now.
Yeah, I do love this program. Very nice. I tried another program, CircuitVerse, and it was also very nice and had a few features, which this had as well, like a built-in counter, which I had to code myself, had to make myself. But it's just online, and the problem with it is just, it's great, but it feels like, I think Logisim Evolution is slightly better because I can load files in directly with my files.
Do you think that maybe you see yourself developing CPUs or something like that in the future?
Yeah, so if you want
quantum CPUs.
If you want a really shoddily made 8-bit broken calculator, then phone me here.
13, no, it's not too bad. But yeah.
Even
but I'm
better,
talking about the future.
if you want your next gen computer made by a 13-year-old who doesn't really know how to use this digital logic simulator, then call me. Throw away your NVIDIA GPU.
In your past life, you've picked up stuff, but in your future life, would you like to maybe develop quantum processors and stuff like that? It's quite interesting.
Maybe we have to see.
Yeah, cool. But it's interesting. I'm sure this is some value to someone out there. This.
I can barely do maths right now, so imagine trying to do quantum mechanics.
Yeah, the problem is that you're very exceptionally good with logic, but the maths.
Like I'm struggling
you only spend an hour a week on maths, which is really bad.
Oh, well.
And you're at grade 11 or something, so that's not too bad, I suppose. But anyway. Great. I think this is super. Very interesting. Genius! Again, I'll say it again. Genius!
Yes.
First one in the world.
We must have your face saying genius as a thumbnail.
Genius. First one in the world that's done this. Maybe we can put that as YouTube there. First 13-year-old designs...
shoddy broken calculator.
Anyway.
I can't calculate.
Well, have you done that? Can you do that?
Yeah, it has the ALU. It should be able to calculate stuff.
Okay, cool.
Yeah.
Well, let's call it for the next time when you actually have a proper little game on this. And then maybe you can share it on... Can you share this stuff with the...
I should be able to
Logisim?
share it. So if I make sure to save it. Yeah.
And then you can give it to other people to download. Maybe you can GitHub this. This is just in a text format.
I think it's just .circ file, so I can share some
Okay,
basic
cool.
programs. And
Yeah, it'd be quite
I guess
interesting
I'll
for
also
people.
share my broken, heavily stolen converter that converts it to bearable microcode.
Cool. Maybe what you should do is you should get some anyway, that's for another
But yeah,
conversation.
I'll patch up the computer, and then the next version will be, and hopefully the next video will be upgrading this to actual assembly.
Okay, cool. Great.
Okay.
Nice. Cheers. Bye.
Bye.